Okay, welcome back everyone. Today we're going to learn the rest of those trig derivatives and also practice that chain rule that we've learned and hopefully get it better and better. Okay, so here they are, the derivatives of the trigonometric functions. So you already know the first two that we've introduced, okay? That the derivative of sine is cosine and the derivative of cos is negative sine. But now we have these new functions and their derivatives. So there's a couple things that I can get you to help you to remember, but the basic thing right now, guys, is that you need to get this down in your notebook. You need to make flashcards of these, and you need to commit them to memory by next class. So you shouldn't be stumbling over it. As soon as I ask you what the derivative of secant x is, you need to be able to tell me, oh, that's secant x tan x. So like I said, there's a couple tricks that I can kind of point out to you, and hopefully that will help you. If you notice here, all of the derivatives that start with c, so when I take the derivative of cos, cotangent, and cosecant, for all of those, the derivative is negative. So the first kind of hint is if when it starts with c, the derivative is negative. Okay? Then I kind of look at them in pairs. So I notice that these two group together, that the derivative of tan and the derivative of cotangent, that their answers are both just a single thing. So derivative of tan is just secant squared x, and the derivative of cotangent is negative cosecant squared x. So it's one term, but it's squared. So the derivative of tan and the derivative of cotangent are going to give you back squared functions. And then you can also notice that the letters match up, that here the derivative of cotangent is negative, like we talked about, but then it's also cosecant. So cotangent gives you a derivative of negative cosecant squared. Okay? And then the last pair here is the derivative of secant and the derivative of cosecant. So these you can memorize. They give you back two things, secant x tan x for the derivative of secant, and the derivative of cosecant is negative cosecant x cotangent x. You can remember that the derivative that you start with, or I'm sorry, the function that you start with starts off as the first one. So when you take the derivative of secant, you get secant x and then times tangent x. When you take the derivative of cosecant x, you get negative, of course, again, cosecant x and then cotangent x. Like I said, these are just little tricks to help you memorize them, but it's up to you. You have to commit those to memory. Okay, so we're going to get rolling on some practice. Again, each of these, we're going to practice taking the derivative with these new trig functions, but we're also going to be seeing the chain rule in each one of these. So the first one is asking us to take the derivative of f of x equals secant 10x. So here, as soon as you are secant of 10x, so 10x is your inside and the secant is your outside. So if you remember what we talked about last time, we said when we did the derivative using the chain rule, we would take the derivative of the outside. So the derivative of secant is secant. Now we said we are going to keep the inside. The inside in this case is the angle, and the angle is 10x. So when we get to the angle, we're not just going to write secant x tangent x. Instead, we're going to do secant of the angle, and so my angle here is 10x times tangent of the angle that I began with. Remember, we keep the inside. And then times the derivative of the inside, well, the derivative of 10x is 10. And so one last step to clean that up, we just put the 10 in front. So 10 secant 10x tangent 10x. And that's the answer. Okay, this next one looks very similar to the one we just did. I want you to pause and try it on your own and then come back to me and see if you got it right. Okay, so looking at this next one, yeah, we were taking the derivative of cosecant, and again, this was your inside, and this, okay, the 5x was your inside, and the function cosecant is your outside. So we take the derivative of the outside, which we know is negative cosecant of the angle, keep it the same, times cotangent of the angle, again, keep it the same, times the derivative of the angle, the derivative of the inside, which is 5. And then I just cleaned it up and rewrote it. Okay, taking a look at this next one. So we're given f of x is equal to x cubed times tangent 4x. So that times sign isn't there, but we need to recognize here that we have x cubed and then we have times tangent 4x. So we definitely have to use the product rule. And then when we get to taking the derivative of tan 4x, we'll have to use the chain rule. Okay? So remember with the product rule, it's first, so in this case that'd be x cubed, times the derivative of tan 4x. So this is where we're using the chain rule within the product rule. So, excuse me, remember the derivative of tan, okay, is secant squared. Keep the inside, times the derivative of the inside would be 4. Okay, plus, so that was the derivative of the second. So this was first times the derivative of the second was this whole thing, plus. So now we're at second, which is tan 4x, times the derivative of the first, which is your 3x squared. Okay, so now anything on the left-hand side that can be cleaned up, we should. And so if you notice here, we have this x cubed times secant squared 4x times 4. So the x cubed and the 4 can come together, and that would be 4x cubed, and then secant squared 4x, plus the 3x squared, and then tangent 4x. Now, as we talked about before, if these are multiple choice, they might do something like pull that. If you notice here, both of these terms have an x, okay, x cubed and x squared. So they could pull that x squared out and factor it out. They could also leave it like this. So you should be aware and be able to match up no matter what your multiple choice answer looks like. Okay, so taking a look at this next one, hopefully your gut is telling you that you're going to use the quotient rule, and in fact we are. I just want to rewrite what I'm given here so that I see in the numerator, I have cotangent of x squared. And so we want to make sure that we are aware that that's the x that's being squared and not the whole function. So you want to be aware of that. And so sometimes you want to put parentheses around that x squared, around the angle, if they don't put them there for you. All right, so now when I do g prime of x equals, okay, so we're going to have a fraction. The quotient rule gives us back a quotient, okay? So it's low times the derivative of the high. So the derivative of cotangent x squared. Well, the derivative of cotangent, okay, I'm going to kind of bracket this off, is negative cosecant squared. Remember, we keep the angle, so that's x squared, times the derivative of the angle, which is 2x. Okay, so that was low d high minus high. I'm just going to copy my numerator. D low, which the derivative of x is 1. So it's your option. You can write that there, or you can just leave it as is. Okay, all over low squared, so x squared. All right, so just clean that up. All right, so in the numerator, even though we put these brackets here, okay, we have x times negative cosecant squared x squared times 2x. So everything to the left of the minus sign is multiplying, so we can go ahead and combine the x and that negative sign and the 2x. So we would get negative 2x squared cosecant squared of x squared minus cotangent of x squared all over x squared. Okay, and that's as much as we can do. Okay, our fifth problem here. We have y equals 2, which is a constant, times cosecant to the fifth of 3x. Okay, so our angle is 3x, but you notice that you have this fifth power, and that fifth power this time is on the function. So it definitely would help to rewrite this so that we recognize what is being raised to the fifth power. So we're going to rewrite this as 2 cosecant of 3x. That is what's being raised to the fifth power. Okay, so it's not on the 2, it's not on the angle, the 3x, it's on the function. So the function of the angle, so it's on that whole piece, okay? So when I now do take the derivative of this, okay, I actually have, this is an example of one where you have the chain rule inside the chain rule. So first type of chain rule, right, are the exponents here. So this 5 is an exponent. I have to take care of that by using my product rule and pulling that down, multiplying it times the 2, and decreasing this exponent by 1. But then I have to take the derivative of the inside, and the derivative of the inside is another chain rule. Okay, so let's get started on doing this. So we would first of all, like I said, use the power rule, multiply the exponent of 5 times your coefficient, your constant there. So 10, okay, keep the inside, cosecant of 3x. Now decrease your exponent by 1. Now times, make sure you realize that's multiplication, the derivative of the inside. Well, to take the derivative of cosecant 3x. Okay, the derivative of cosecant is negative cosecant, keep the angle, times cotangent, keep the angle, times the derivative of the inside, which this inside now is that angle, which is just 3. Okay, so I'm just going to clean this up. Notice everything is multiplying here. So there is no, even though this is a negative here, it's all multiplication. So anything that can multiply, we're going to go ahead and do that. So we have this 10 here, we have a negative 1, and then we have this 3. So we're going to pull that all out front and get negative 30. All right, now I'm going to rewrite this cosecant of 3x to the 4th as cosecant raised to the 4th of 3x. That's how we kind of usually see it. And then we already took care of the negative, so then it's just cosecant of 3x times cotangent of 3x. Now some of you might recognize or say, well, wait a second, I have cosecant to the 4th of 3x here, and here I have another cosecant of 3x. Well, that's correct. And so when we are multiplying two powers with the same base, you can go ahead and add the exponent. So actually this becomes negative 30 cosecant, to the 5th 3x times cotangent 3x. And that is our final answer. Okay, some of these we're cruising through pretty fast. Please make sure that if you are not following or you get lost, you're pausing, rewinding, and re-listening and making sure you are understanding for yourself. Okay, remember these are your notes. You want to make them as powerful as you can for yourself. All right, I actually want you to get number 6 down and then pause and try this one on your own and then come back and see if you get what I got. Okay, so let's take a look at my answer here. First of all, I recognize that it was in fact a product, so I went ahead and broke those off to see that. Okay, so then f prime of t was first times the derivative of the second. So take a look, make sure yours matches mine. Make sure that your angles inside those parentheses are 2t. And then that you took the derivative of 2t and got 2. Plus, second times the derivative of the first is just negative 5. Okay, I clean that up by multiplying the negative 5 times the 2, put that out front. Sorry, the negative 5t times the 2, negative 10t. Then secant 2t, tan 2t, and then I just put the minus 5, secant 2t. Okay, hopefully you're recognizing that in fact we have some like terms. And again, this is more for multiple choice to recognize if you are if you have an answer and it doesn't look exactly like your choices, you might think about, did they factor something? So in fact, we could factor out a negative 5 and a secant 2t from both sides. So negative 5 secant 2t. And that would be from the left-hand side and the right-hand side of my parentheses, okay? And so what would be left then inside, okay? Well, I would have 2t, my secant 2t would be gone, but my tangent 2t would be there, okay? And you might want to put a, all right, and then minus, all right, well, these match exactly, and so we would have a 1. And actually, we should have a plus 1 because we're dividing out a negative 5 there. So we would have plus 1. And all you're kind of mentally doing is checking to make sure that if you were to distribute back through this piece here, okay, that if you were to distribute that back through, that you would end up with exactly what you have here. And in fact, you do. So you're all set. Like I said, both answers could be given. You just want to be prepared either way. Okay, again, I'd like you to get this one down, pause, and try it on your own. Before you go off, I want you just to, take into consideration that you want to rewrite this h of x function because you have this squared on the tangent. So think about how we've done that before. Do that first. Okay, so take a look, compare, and see how you did. So first of all, like I said, we want to rewrite this. So it's h of x is equal to -4, and I just took and rewrote this as tangent of 3x minus 2 squared. So I have my squared on the outside of the whole function. Okay, so again, I notice that I have this power here, so I first need to take care of that by multiplying that times the coefficient in front and decreasing my exponent by 1. So that's where I got -8. I kept the inside and then decreased my exponent by 1 times the derivative of the inside. The derivative of tan of an angle is secant squared of that angle times the derivative of the angle. So secant squared, keep in parentheses 3x minus 2 times your 3. Okay, and then I cleaned it up. It's all multiplication. So the -8 and the 3 multiplied to give me -24. This just becomes tangent of 3x minus 2 because you can put a first power, but you don't need to, and then times secant squared of 3x minus 2. Okay, this last one is a little bit messy, so stick with me. And you've had lots of practice with these, so you should be totally fine, right? So find the equation of the tangent line and the normal line. So anytime they're asking us to write the equation of a line, we need two things, right? We need a point, and we need that slope. Okay, so first of all, we're going to worry about the point. So we have our x value is pi over 8. So we need our y value. So that means I need to take the function that's given and plug in pi over 8 in for x. Okay, so that's cosecant of 2 times pi over 8. So I'm going to write it like that. Plus cotangent of 2 pi over 8. Because 2 times pi over 8 would be 2 pi over 8. Okay, you might be a little nervous, like 2 pi over 8, I've never heard of that angle, but just think about it, take a deep breath, and you realize that 2 pi over 8 can in fact be simplified to pi over 4. Oops, this was supposed to be cotangent. Okay, pi over 4. Okay, now pi over 4 should definitely be an angle that we're familiar with. Okay, so I'm going to hold off on, I'm not going to do the work for the slope here, so I'm going to continue on over here. Okay, my pi over 4, so if we're thinking about our unit circle, okay, pi over 4 is the one that splits between 0 and pi over 2, so that's this angle right there. And we know that on the unit circle, so if I were to draw the unit circle in, okay, on the unit circle, that point right there is the easy one to remember, root 2 over 2, root 2 over 2. Okay, and we're in the first quadrant, so everything's positive. Okay, so let's remind ourselves here. Cosecant, okay, is the reciprocal of sine, and sine is our y value. So our y value here is obviously root 2 over 2. So off to the side, I'm just going to kind of clean this up. Reciprocal means to flip it. So I would be flipping root 2 over 2, and it'd be 2 over root 2. I'm going to rationalize that unless I have it memorized, okay? And that's 2 root 2 over 2, which just becomes root 2. All right, so now I know that this piece here, cosecant of pi over 4, is just radical 2. Okay, now plus cotangent of pi over 4. Okay, cotangent is a reciprocal of tangent. Tangent is y divided by x. Well, if I notice here, my y and my x are both the same. If you divide any equal quantity by itself, you're going to get 1. So rather, if you're looking at tangent, y divided by x, or cotangent, x divided by y, either way, the cotangent or the tangent of this angle is 1. So this is my y value, radical 2 plus 1. Okay, you can't do anything more to simplify that. All right, so now I'm ready to work with that slope that we were talking about. All right, so now for the slope. So obviously for the slope, I need to do the derivative of the given function. Okay, so the derivative of this function. Well, we have two pieces here, okay? Notice that they are being linked with a plus sign, not a multiplication. So you're going to do the derivative of cosecant 2x, and then you're going to do the derivative of cotangent 2x, and you're just going to add them together. So cosecant, the derivative of cosecant is negative cosecant of the angle, cotangent of the angle, times the derivative of the angle, plus the derivative of cotangent is negative cosecant squared of the angle times the derivative of the angle. Okay, so if I clean this up, f prime of x is going to be negative 2 cosecant of 2x, cotangent of 2x, minus 2, so I'm just moving that 2 in front with the negative, okay, cosecant squared 2x. Okay. Okay, so to continue working here, I now need to find my slope at pi over 8. That's the x value I was given. Okay, so it's negative 2 cosecant. All right, we already did up above 2 times pi over 8, and we know it's just going to be pi over 4. So I'm just going to kind of save that step and put that in. Cotangent of pi over 4, because again, it's 2 times pi over 8, minus 2 cosecant squared of 2 times pi over 8, again, is pi over 4. Okay, and again, I already found the cosecant of pi over 4 and the cotangent of pi over 4. Again, I'm not going to redo my efforts. I'm going to go ahead and take steal those values from up above. I found that the cosecant of pi over 4 was radical 2. So negative 2 square root 2. Okay, now the cotangent of pi over 4 from up above I found to be 1, so times 1, minus 2 times the cosecant of pi over 4. So this here, okay, I'm just going to kind of go down here. This is really saying 2 times the cosecant of pi over 4 squared. So you're taking the cosecant of pi over 4, you're squaring it, and you're multiplying it times 2. That's what this is communicating. Okay, so cosecant of pi over 4, remember, was radical 2, and then we're squaring it. All right, so your slope here would be negative 2 radical 2, and then minus, all right, radical 2 squared here is going to be 2, times your 2 is going to be minus 4. And so our slope, our m value, is negative 2 root 2 minus 4. Okay, so now we have our slope, and we have our, what's it called? Our y value, and we are given our x value. So I'm just going to kind of put our point here, just so we have it. Okay, so our point here was x is pi over 8, comma, root 2 plus 1. Okay, and there's our slope. So we have two equations to write. So we have our tangent, okay, and then we have our normal. So for the tangent, we would say y minus, all right, now if my y value here is a binomial, I have to put it in parentheses, root 2 plus 1 in parentheses is equal to my slope. Again, same thing, negative 2 root 2 minus 4 times x minus pi over 8. So that is the equation of my tangent. Okay. Okay, and finally the equation of my normal. Same thing, except for you're going to do the negative reciprocal for the slope. So y minus radical 2 plus 1, again in parentheses, is equal to. Okay, so I'm going to do negative 1 over negative 2 root 2 minus 4 times x minus pi over 8. And just one last bit of cleaning house. Like I said, you could leave it like this. If this was open-ended, this slope would be fine. You don't have to clean it up. But for multiple choice, they probably will clean it up. And if you notice, the numerator and the denominator there all have a negative. So probably they would rewrite this as 1 over 2 radical 2 plus 4. So they divided a negative out of the top and a negative out of the bottom, which is okay, because in essence you're dividing by a negative 1 over negative 1, which is 1. All right, and then times x minus pi over 8. So again, just for multiple choice purposes, that would probably be the cleanest answer. But once again, both would be accepted. Okay, so as I said earlier, this was a lot today. The chain rule, getting that down and having that and being able to do it automatically is so important. And just as important is knowing those trig derivatives. Trust me, learn them now, memorize them, because otherwise it will continually come back to haunt you. All right, thanks a lot. See you next class.